We now move into the test program for the XADC, but before I just jump into that, I want to talk a little bit about basic circuits. Specifically, the ADC we're using expect differential input, so it has a positive and negative ports for each one of the channels, and it's actually operating in unipolar, so it's expecting that the negative input or the negative port should be connected to 0 to the ground, and the maximum that it can actually see is 1 volt. So to guarantee the specification, what we have is we have to make sure that the input to the ADC is just between 0 and 1, and the way we can do it is using a very simple voltage divider. So this voltage divider does the following. So the VCC is the voltage available on the board in some of the pins on the ADC, specifically the XADC that we're going to be using. So it gives us about 3.3 volts, and we have a ground of 0. So in order for us to get some 1 across this particular 10 here, we can actually use a voltage divider. So we take about 2.3 in here volts all the time, and here is up to 1 volt. So if you do the calculation using the voltage divider, you can see that the minimum we have, if this potentiometer is actually set to 0 volt, it's actually 0 volt, and the maximum when this is 10K, it's actually 1.03 volts, which is actually within the specs. So our specs have to be between 0 to approximately 1 volt. These are not basically these are not the only values that you can actually have this. You might have it differently, but just make sure that whenever you have in the ADC input, the negative part should be connected to 0, which is ground, and the positive part should be connected to something that can go all the way up to 10K. If you're using 22K, it's up to whatever you have. I have something a little bit different, and I'll show you shortly. Okay, so now we move into the test program to see what we can do with it. So here's the test program, and what I have done is actually it's the sampler test that I gave you that has so many tests in it. What I did is I just commented everything and just kept the ADC check because this is what I'm interested in. And in the ADC check, just so that it's a little bit easier to track, what I did is I actually went in here and just modified the sleep MS from 200 milliseconds to 2000, so it waits to 2 seconds. Okay, let's see. Let's just read it very quickly. So what it does, it takes the ADC as an input. It also has the LEDs if you want to actually change the port or actually to display something on the LEDs, which it will. It goes through a few iterations, exactly 5. What it does is actually read the ADC number 0. It actually reads it as a raw number. Okay, and then it's basically shifted by 4, and then it writes it to the LED. So what the LED is doing is actually the writing whatever is on ADC 0. That's basically what the LEDs will show, and we'll see it shortly. At the same time, we're going to actually go and send to the UART, we're going to send the voltage across the FPGA, and this is using the read FPGA VCC from the driver. And then here we're going to be reading number 3, and we're going to see that the third reading is actually the temperature, and we're going to send it, and then another reading in here. And these readings are basically the analog channels, all of them. It will go through 0, 1, 2, 3 all the way, basically the 4 auxiliary channels, and we're going to read them one at a time. Okay, so we move into the board. So I'm going to move slightly to the board to show you what's happening on the board. So here's what the board is showing. On the board, I have utilized the XADC in here, the JXADC. So this PMOD is the analog one. You see a lot of wires in here, and I'll explain to you what's happening. So what's happening is this is my voltage divider, and I decided to use a potentiometer for it. I'm not exactly following the specs I just showed you, and the reason why is I don't have all the resistors, but this is as close as I can get it. It's close enough. It doesn't give me exactly 1 volt to the output, but it's close enough, as you'll see shortly. So what I need you to pay attention to is what I connected in here. It might seem a lot again in here, and the yellow ones are kind of useless because I am basically connecting to the ADC. So I have ADC 0 for the first one. Let me just show you. So I have ADC 0 in here, and then ADC 1, and then ADC 2, ADC 3, and then I have a ground, as this actually shows you in here. Hopefully you can see it, and then 3.3 volts. So what I did is I took the red one is the 3.3 volts, and the black one is actually the ground, and I just basically connected it to the wipers of the potentiometers in here. And the one in the middle, what I did is I took it to the positive, which is the orange one. I took it to the positive of the channel 0. And channel 0 as well, I don't know if you can see it in here, but channel 0 should be connected to the ground. So what I did is I took some of these black wires in here and I connected it from the ground that is here, which is also connected to the ground of the potentiometer all the way in there. So the negative port, you need to make sure that you connect it to ground. So this is one of the most mistakes I've seen, that you don't connect the second one here to ground. So you need to connect this to ground, and this is actually the signal you're trying to sample. So for the other ADC channels, in our test, even though that we're showing them, I don't want to just put so many potentiometers in here, but you could use for each one of the ADC like 1, 2, 3, and 4. You can use four different potentiometers if you choose to. But for now, I'm just showing you one. But because these ADCs are just left open, so in order for me just not to see anything coming on their numbers, what I did is I took the positive edge, connected it to the negative edge. So each one of these yellow wires is connecting the upper ADC pin, basically positive to the negative, positive to the negative, positive to the negative. Effectively, what I'm doing in the differential input is I'm just making them 0, and hopefully I get to see on the ADC that it's a 0. Okay, again, so what the test is doing, it actually goes every 2 seconds, reads the first one as raw, and it actually displays that value on the LEDs, and then it also is sending certain things to the PuTTY or to the console. So let's go to the console to see it. Okay, so here's what the console is showing me at this moment. It's actually showing me the following. It's telling me that the FPGA VCC and the temperature, and it's just basically telling me the reading, which is 1. Basically the VCC that it's reading is actually 1, and the other one is actually 4.1, so forth. Okay, so let's see that this is basically 41 Celsius. That's what it reads, and then it reads all the different channels one at a time. Every 2 seconds it repeats the same thing. So let's take a look at these channels. So I'm going to start moving the potentiometer, and hopefully you get to see that 0 will actually increase a little bit, and you can see that it is slightly changing, like I'm moving into the opposite direction. Let me just do that. It will go all the way to 1, and that's basically the maximum it can go. It cannot go more. So if I remove these yellow wires, I'm just going to move this down a little bit. Okay, I'm just going to move it down a little bit. There you go. Okay, so basically this is exactly in the middle. So if I remove these yellow wires in here, so let me just do that. It actually is susceptible to noise. So you'll see that the other channels start reading something. And because we're dealing with analog signals, so these other channels are actually being affected by the first channel, just because they're just left open. Okay, and that's why I connected all these yellow. But technically, you do not need them. If you want to ignore them, you can just basically ignore these numbers. Okay, and that's basically how the test program is. You can definitely modify it, do something with it. Like, it's up to you to modify this code and generate whatever you want with it.